Hello everyone, welcome to my U Programming Club. Today we will be solving another daily Leetcode problem, and the problem's name is constraint subsequence sum. So the problem statement goes like this: given an array of integers called nums and an integer k, you have to return the maximum sum of non-empty subsequence of that array, such that the following condition is satisfied. So among two consecutive elements, among let's say if you pick this element 20, so the previous element that could have been picked, uh, leftmost element can be this 10. Okay, if you see the differences between the indices of 10 and 20, it will be 2. It will be 2 places ahead. 20 is 2 places ahead of 10. So it should not be greater than k. So this is the condition that is to be satisfied. And a subsequence, those of you who do not know what a subsequence is a sequence of array elements that can be obtained by deleting 0 or some of the elements, provided that the remaining elements that are not deleted remain in their original order. For example, uh, let's say you consider this particular array as your input. So a valid subsequence can be 135. It cannot be 153 because 3 is coming before 5 in the original array. So the relative order is not maintained here. So it will not be a valid subsequence. It is a valid subsequence. Okay. So among all such possible subsequences, valid subsequences of this type, you have to return the subsequence which is having maximum sum. Okay. So how we will be solving this problem? First of all, let's have a look at the constraints. So the constraints of the problem are like this. Uh, K and length of the array nums will be of order 10 raised to power 5, and the elements will be ranging from minus 10 raised to power 4 to 10 raised to power 4. Okay. So let's consider a brute force approach to solve this problem. It will be to generate all the subsequences of the given array and pick out the valid subsequences. Valid subsequences are the subsequences that are following this particular property, such that the every two consecutive integers in the subsequence differ by at most k places. Okay. So if this property is satisfied, then it's a valid subsequence. So we will be picking such uh, valid subsequences among all the possible subsequences and then finding the maximum sum among them. Okay, it will take more than order of 2 raised to power n time complexity, and n maximum value here is 10 raised to power 5. N is nothing but length of nums array. Okay, so 2 into 10 raised to power 5 operations will be more than or let's say for now these number of operations are required. So these are very much greater than the operation limit of 10 raised to power 8 operations. So your brute force solution will give you time limit exceeded and the solution will not be accepted. So we have to optimize the brute force approach. So how we will be optimizing? What we will do is, first of all, to proceed further in the solution, you should be knowing about sliding window technique applied for the problem of maximum of all subarrays of size k. Okay, so this is a prerequisite. You should be knowing this particular approach. So let's say how we can apply this to solve our problem. First of all, let's consider only, let me erase this. Let's consider the previous example itself. 1, 2, 3, 4 and 5. Okay, let's mark the indices 0, 1, 2, 3, and 4. So if you let's say we are considering 4 to be the last element of the subsequence. Okay, uh, there is a subsequence that is ending at 4. So what will be the maximum sum of such subsequences that are ending at 4? Okay, so 4 can be contributing to subsequences ending at 3, subsequences ending at 2. If it will go beyond that, so the difference between 4 and the previous subsequences, let's say ending at 0, will be 3 minus 0, which is 3 greater than k. So it will not be a valid one. So as you can see, only these two are the valid ones to which 4 can be providing its contribution, so that the subsequence can be ending at 4. And among these two subsequences, these two options, you have to pick the maximum one, which is giving the maximum sum. Okay, so if let's say two subsequences are given, uh, one is 1, 2, 3, and 4, another is 1, 2, 4. So this highlighted part is common among both of them. To calculate this particular part, you will be doing extra work. You will be calculating it twice. Okay, so this particular subproblem is overlapping. So first property required for applying dynamic programming is being satisfied, which is overlapping subproblem. Those of you who are new to this property, I will be providing a link of article describing this. Okay, now if let's say we have to find the maximum sum of subsequence ending at 4, then we should know the result for 3 and 2. Okay, so we should be knowing the result of the subsequences ending at 3, or as a maximum sum of the subsequences ending at 2. So it can be easily observed as solution of a bigger problem. For problem of 4, we can easily find its solution with the help of smaller problems solutions. So another property, which is optimal substructure, is being satisfied here. Those of you who are new to this property also, I will be also providing a link for this particular property. Then once these two properties are satisfied in a problem, we can easily apply dynamic programming approach here. Okay. Okay, so dynamic programming approach, let's see how we will be applying it along with the sliding window. So sliding window will be used to find the maximum sum subsequence among these two possible ones. What are the possible ones? Subsequences ending at 2 or subsequences ending at 3. Which of them will be giving more sum when combined with 4? Okay, so for that we will be using sliding window. Okay, so let's see the implementation part. So next till this will be a data structure that we will be using to store the maximum sum of our subsequences ending at a particular index. Okay, and initially we will initialize it to the values of the given nums array to account for the subsequences of size 1. Let's say uh, this is the given nums array. Let me take another slide. Nums array, let's say be 2, 3, 4. Okay, so let's say I decide to take only this particular element. This is also a subsequence. Okay, to account for size 1 subsequences, we will be initializing it with the nums. Okay, so then we will be using sliding window approach. This is nothing but sliding window approach along with dynamic programming. Okay, uh, for all the subsequences ending at this particular index, we will be finding the sum among them, and it will be the maximum sum available. Okay, and along that we will be updating our final result. We will be updating our final result. Okay, and then we will remove all the subsequences. For example, in the previous example I told you that this zeroth index cannot be considered because it is more than k places beyond 4. Okay, so we will be removing such uh, elements from the current window will be of size k only. As you can see, it is of size 2. Okay, so remove all the subsequences that are lesser than the current one. uh, First of all, we will be removing all the subsequences that are not necessary, and then we will remove all the subsequences to which current element cannot make contributions to. Okay, so and if let's say your current subsequences, the subsequences ending at a particular index whose sum is also maximum is having some greater than 0, then you will enqueue it into your queue. Okay, so and at last you will be returning your result. So you should be very well versed with this particular uh, technique to understand the solution. And if you are still having any doubts, please feel free to ask them in the comment section. I will be more than happy to answer them. So thank you for watching. Thanks.